Hi, I'm Dan Abel, and in this video we're going to draw the interaction between two bar magnets. In order to draw the interaction between two bar magnets, it is best to start by looking at a single bar magnet. And every magnet produces a magnetic field that is stronger near its poles. As you learned in a previous lesson with electric fields, the stronger the field, the larger number of field lines should be in that area. So we will need a larger number of field lines near here, near the poles, and then those field lines should spread out as we move away from the poles and the field gets weaker. Magnetic field loops are directed from the North Pole to the South Pole outside the magnet, but because magnetic fields need to be complete loops, the magnetic field also exists inside the magnet. Let's see if we put all this together, what this looks like. So drawing the magnetic field created by a single bar magnet will look like this. We have more field line density near the north and south poles. We have complete loops that run from north to south, and then are the lines that then complete the loop. So without drawing them all inside the magnet, they would look like this. Magnetic field lines will never cross, and inside they will be going from the south to the north. So north to south outside, and then to complete the loop, south to north inside. And all of these would have a connection. And then we see that as we get farther away, either above or below, the field lines are also less dense. Now, when two bar magnets are placed near each other, you have to look at whether you have the same or opposite poles facing each other. When opposite poles are placed near each other, the field lines will connect to form complete loops through the two magnets. But when like poles are placed near each other, the field lines do not connect and repel away from each other. So here's the case where we have two opposite poles, and we can see the field lines connecting. Now, not every field line connects to two magnets, but if you take one of these outside loops and you complete it through the magnet on the right, and then into the magnet on the left and around, we get this combined loop, and these two magnets are attracted. However, in the case where we have the same poles near each other, these will not form loops together. The loops will still be complete, but notice that as opposed to the last example, part B, this time there's complete loops for each individual magnet, but they appear to repel away from each other between the two magnets. These will repel. So the key takeaways here are magnetic field lines, regardless of how many magnets you have, will run from north to south outside the magnet. If it's attracted, at least some of the lines will connect through both magnets. If it's repulsive, they will not. Experimentally, you can map the magnetic field of a magnet using a small compass, placing it at different points around the magnet, and drawing arrows to show which way the needle is pointing.